I've already shown in the other video how you can get this table of values from drawing two very basic triangles and then just doing a little bit of SOHCAHTOA and a little bit of Pythagoras. There is patterns within these numbers though that can help you as well. So that's what this video is about. First thing to spot is notice how the sine function and the cosine function produce the same values but in reverse. So sine of 0 is the same thing as cos of 90. Sine of 30 is the same thing as cos of 60. Sine of 45 is the same thing as cos of 45. Sine of 60 is the same thing as cos of 30. And sine of 90 is the same thing as cos of 0. And that's actually always going to be the case whenever you have two angles that add up to 90. We call them complementary. And that is why cosine has the name cosine. It's complementary to the sine. So cosine. Anyway, key thing is they reverse. So that's one thing to spot. Right, I'm going to show you another pattern. So I've written out this table of values in a slightly different way now. So I'll let you just look at that just for a moment so you can get your head around the pattern, and then I'll show you that it is the same thing as what I wrote at the top there, just in a longer but clearer way, hopefully. You can see the denominator is always a 2, and the numerator is always a square root of 0, 1, 2, 3, 4. And I'll show you that they're the same thing. The square root of 0 is 0. 0 divided by 2 is still 0. The square root of 1 is 1 divided by 2. The square root of 2 is, well, we just have to write that as root, leave it as root 2. So we'll leave this as root 2 over 2. The square root of 3, we can't do that, so we'll leave it as root 3 over 2. The square root of 4 is 2. And 2 over 2 is 1. So you can see that we've got the same values as we had at the top up here, with that simple pattern of just the square root 0, 1, 2, 3, 4, and always a 2 on the bottom. Then for the cosine, like I said before, we know it's going to be the same as this but in reverse. So that's going to be a 0, this is going to be a half, that's the root 2 over 2, that's the root 3 over 2, that's the root 4 over 2, which is just, as we saw before, 1. And then in terms of the tan, now when you do A-level maths, you will learn all about something called an identity, and basically tan is always sine divided by cos. You don't need to know about it for GCSE, but the tan of an angle is always the same as sine of the angle divided by cos of the angle. And the fact that I've written these with the same denominators is helpful, because it means when we're dividing we don't need to worry about that. So all you need to do is look at the numerators. Root 0 divided by root 4, root 1 divided by root 3, root 2 divided by root 2, root 3 divided by root 1, and root 4 divided by root 0. Right, root 0 is 0 divided by root 2, well 0 divided by anything is going to be 0. Root 1 is 1, root 3 we can't do anything about that, but we can rationalise this. If we rationalise that, we'll get root 3 over 3. Root 2 divided by root 2 is 1, because whenever you divide anything by itself, it will be 1. Root 3 divided by 1 is just root 3. Root 4 divided by 0, well, we're not allowed to divide by 0, so this is actually undefined. It doesn't have a solution, which is why I've got a dash up there. But we can see that these give these values here. So that is how we can create these table of values. If you just remember this row here like this, so the root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. Just remember that pattern and then you can simplify it. Cos is the opposite way round. And then for tan, you need to do the numerator here, divide by the numerator here, and then simplify all of that. So that's an alternative way of you getting these. It's still, in my opinion, it's still way too much information, and it doesn't really give you a proper understanding of where these values actually come from. So I don't like this method. Some people like it. I much prefer these methods here. But some of you may like that as a little trick to help you just remember the patterns in a quick way.